Welcome back to yet another episode of Computer Graphics. Myself, Fazira Razak Hamza, Assistant Professor, PG Department of Computer Science. So, let's get started. Again, with the same unit, Unit 1. I already said that computers are a powerful tool for the production of pictures, right? Not only production, we have to present it on a screen, right? So for presenting it on a screen, I have selected some video display devices. So today we'll discuss about some video display devices. So first video display device, we all know, that is refresh cathode ray tubes, that is CRT. See, here I have given a picture on how an electron gun with accelerating node is working and the basic design of a magnetic deflection CRT. Figure 1 represents basic design of a magnetic deflection CRT and figure 2 represents operation of an electron gun with accelerating node. So we'll see what are the components of a CRT. See, we have a phosphor-coated screen, an electron beam, magnetic deflection coils, focusing system, electron gun, connector pins, heating filament, anode, cathode, electron beam path, and control grids. So, let's see how it is going to work. See, we'll go back to the picture and see how it works. See, we have a beam of electron, right? Electron beam is there, right? They are known as cathode rays. Okay. Here, the electron beam emits a beam of electron by an electron gun. You can see an electron gun there. It emits a beam of electrons. That is cathode ray. Okay. This electron gun or electrons that are being emitted by the electron guns passes through the focusing and deflection system. We can see a focusing and deflection system there. The electrons passes through the focusing and deflection system that direct the beam towards the specified positions on the phosphor-coated screen. Okay, the phosphor then emits a small spot of light at each position contacted by the electron beam. So whenever the electron beam contacts the phosphor, it emits a small spot of light. So that is why we are seeing picture on the TV. This light produces a picture on the TV. So we can say that the primary component of an electron gun in a CRT are the heated metal cathode and a control grid. You can see a control grid in the second figure and also a heating filament along with a cathode. So these are the primary components of an electron gun. So the heating filament supplies heat to the cathode by directing a current through a coil of wire called the filament inside the cylindrical cathode structure. So all these things happens inside the cylindrical cathode structure. A heat is passed by directing a current through a coil of wire. So this causes the electrons to boil and heat the cathode surface. Okay, sometimes we can see that the television is becoming heated, right? It emits so much of heat, right? That is because the electrons are getting boiled up inside that. So, in the vacuum inside the CRT envelope, the negatively charged electrons are then accelerated towards the phosphor coating by a high positive voltage. Okay, the focusing system in a CRT is needed to force the electron beam to converge it into a small spot as it strikes the phosphor screen. So we are making the light a bit small. Okay. After a short time, the excited phosphor electrons begin dropping back to their stable ground state, giving up their extra energy as small quantums of light energy. Okay. It comes back to the stable ground state and produces a light energy, giving up their extra energy. So what we see on the screen is the combined effect of all the electron light emissions. A glowing spot that quickly fades after all the excited phosphor electrons have returned to their ground energy level. So as quickly as possible, the spots of light gets fade away after it comes back to the ground energy level. So we can say that the intensity distribution of a spotlight on the screen is greater at the center of the screen. So always at the center of the screen, the intensity distribution will be the greatest. So maximum number of points that can be displayed without overlap. Maximum number of points that can be displayed without overlap on a CRT is referred to as the resolution. So high resolution systems are often referred to as high definition systems. Likewise, another property of video monitors is aspect ratio. Let's see what is aspect ratio. This number gives the ratio of vertical points to horizontal points necessary to produce equal length lines in both directions on the screen. So the main two properties that we have to look on CRTs are resolution and aspect ratio. This is how refresh cathode ray tubes work. See, I have given a small description of resolution and aspect ratio. Now I'll move on to the next topic or next display device, that is raster scan display. As I have written, in a raster scan display system, the electron beam is swept across the screen one row at a time from top to bottom. So this kind of displays, these are most common type of graphics monitor employing a CRT based on the television technology. So these raster scan system employs cathode ray tubes. We can look on to the working of that. Here also there will be, since it is working with the CRTs, we are making utilize of an electron beam. See, as the electron beam moves across each row, the beam intensity is turned on and off to create a pattern of illuminated spots. So here the picture definition is stored in a memory area called the refresh buffer or frame buffer. This area holds the set of, this area means the frame buffer, holds the set of intensity values for all the screen points. Stored intensity values are then retrieved from the refresh buffer and painted on the screen one row at a time, and that is known as the pixel. Here for each screen point is referred to as pixel. See, a very good example of raster scan displays television system and printers. Printers are displaying, printing one row at a time, right? So there is a refresh rate for raster scan displays. Refresh rate on raster scan displays is carried out at the rate of 60 to 80 frames per second. So this is the figure which shows raster scan display which prints one row at a time. Okay. See, Here we can see so many scan lines, right? One row each, we have a scan line. See, at the end of each scan line, the electron beam returns to the left of the side of the screen to begin displaying the next scan line. After each scan line, the electron beam returns to the left side of the screen. Always it returns to the left side of the screen. This is known as horizontal retrace of the electron beam. Returning back to the left side of the screen is known as horizontal retrace. Likewise, we also have a vertical retrace. Let's see what is a vertical retrace. At the end of each frame, the electron beam returns to the top left corner of the screen to begin the next frame. It returns back to the top left corner of the screen to begin the next frame, that is known as vertical retrace. As we all said, it scans from top to left and left to right and top to bottom. That is why there is a horizontal retrace and a vertical retrace. So, our next display device is random scan displays. Let's see what is a random scan display. When operated as a random scan display unit, a CRT has the electron beam directed only to parts of the screen where pictures is to be drawn. So from the definition itself, we came to know that random scan displays are only used for drawing pictures. So here, these monitors draw a picture one line at a time. And for this reason, they are also referred to as vector displays or calligraphic displays. The component lines of a picture can be drawn and refreshed by a random scan system in any specified order. They do not have a left to right or top to bottom order. They can be displayed in any specified order. Here an example for random scan displays. Pen plotter is a random scan hard copy device. So these are basically designed for line drawing applications. They have higher resolution than raster systems. Okay. So, refresh rate on a random scan system depends on the number of lines to be displayed. To display the specified picture, the system cycles through the set of commands in the display file, drawing each component line in turn. After all line drawing commands have been processed, the system cycles back to the first line command in the system. Here the refresh rate is 30 to 60 frames per second. So here, since we are doing vector displays, they produce smooth line drawings because the CRT beam directly follows the line path. This is the random scan display. See, this is how we are drawing a vector picture or a vector or a calligraphic display on the random scan display. Now, we'll move on to the next display device or video monitor, that is color CRT monitors. A CRT monitor displays color pictures by using a combination of phosphors that emit different colored light. So we'll be having a combination of phosphor that has having different colors. Okay, let's see how it works. By combining the emitted light from the different phosphors, a range of colors can be generated. Okay, we can generate a range of colors. There are two basic techniques for producing color displays with a CRT. And what are the techniques? They are beam penetration method and shadow mask method. Now we'll move on to these two techniques, how these techniques are working. So first we will see what is beam penetration method. So beam penetration method is used for displaying color pictures that has been used with random scan systems or random scan monitors. There are two layers of phosphor, that is red and green, which are coated on into inside of the CRT screen. And the displayed order depends on how far the electron beam penetrates into the phosphor layers. So we can say that a beam of slow electrons excites only the outer red layer, and a beam of very fast electrons excites the inner green layer. At the intermediate beam speeds, combinations of red and green light are emitted to show how two additional colors, orange and yellow, will be produced. So, beam penetration method has been an inexpensive way to produce color in random scan monitors, but only 4 colors are possible and the quality of pictures are not so good. To overcome these advantages, we have been developing another method that is known as shadow mask method. So, these are commonly used in raster scan system, including color television, because they produce a much wider range of colors than beam penetration method. So, let's see onto the shadow mask method. This is the picture which represents a shadow mask method. So here, a shadow mask CRT has 3 phosphor color dots at each pixel position. One phosphor dot emits a red light, another emits a green light, and the third emits a blue light. This type of CRT has 3 electron guns, one for each color dot, and a shadow mask grid just behind the phosphor coated screen. The 3 electron beams are deflected and focused as a group onto the shadow mask, which contains a series of holes aligned with the phosphor dot patterns. When the 3 beams pass through a hole in the shadow mask, they activate a dot triangle which appears as a small color spot on the screen. The phosphor dots in the triangles are arranged so that each electron beam can activate only its corresponding color dot when it passes through the shadow mask. So only when these dots pass through the shadow mask, it produces the colors. And the combination of these colors produces many other colors. This is shadow mask method. We do have so many display devices, which I'll be continuing in the next episode. Thank you for listening to my class. Thank you so much.